Okay, I'm back, and now we want to go to the lab that we did on magnetism. So you notice that there is no measuring device that we used for this particular experiment that you need to know about. So under the concepts, you need to know what are the two kinds of materials that can be turned into a magnet. So the two most common magnetic materials. So I'd like for you to know about that. So you can look that one up on Google. Okay, then we looked at magnets. And we looked at how magnets were attracted and repelled by each other. So if I was to give you a picture of two magnets with a north pole facing a north pole, I could ask you what direction would the magnetic force be. Or if I gave you a north pole and a south pole, you should be able to do that. Okay, then we did the magnetic field of a magnet. So you should be able to draw the magnetic field, including the arrows on it, for a bar magnet. So a bar magnet that has a north pole and a south pole, you should be able to draw the lines coming out the top and then going around to the bottom, and then knowing which end is north and then which end is south, you should be able to put arrows on those lines. Okay, so again, if you don't know this, you might want to look it up on Google. You could just type in magnetic field of a bar magnet and then go to images, and it would show you what all this stuff looks like. All right, then we did stuff with electric current. So we showed that two wires that were parallel to each other, when you run electricity through them, are either attracted to each other or repelled from each other. So you might want to find out which way do the electric currents have to go in those two wires to either make them repel or attract. Okay, then you drew the magnetic field of a wire. So I'd like for you to be able to do that. So it had to do with the right-hand rule, and so it's in your notes, and you could also look it up on Google. So we explored what the magnetic field of a straight wire that's carrying electric current would be. Then we did electromagnets. So if I said to you, how would you make an electromagnet if I gave you a wire and a battery and a nail? What would you do? Okay, then we talked about how can you generate electricity with magnetism. And that involved having a coil of wire, and then you took the magnet and you moved it in and out of the coil, and then you should be able to explain to me what happened when that happened. Alright, and then finally we talked about the principle of the electric motor. So I'm not going to have you actually make a motor or draw a picture of a motor for the exam, but the one thing I wanted you to do was, do you remember if you took a magnet and you bent it, you can make it into a horseshoe magnet. So the magnet would go like this, and then one end of it would be north, and then the other end of it would be south. Okay, and then if you took a wire and you put it into that U-shaped thing, so that this is the U-shaped, and then you're going to take the wire and you're going to run it through it. Okay, then when you run electricity through it, it's either going to jump out of the U-shape, or it's going to be pulled into the U-shape. So I would like for you to know under what circumstances would the wire jump out. So it depends on which of the two is the north and which is the south. And it also depends on, is the current going this way or is the current going this way? Now the way that you can figure this out is by using your right hand rule. So do you remember magnetic force, direction of the current, direction of the field? Okay, do you remember that? So by using this right hand rule, you could figure out which way that wire is going to jump. And again, go to Google, type in wire jumping out of U-shaped magnet or something if you can't remember, and you'll probably find it. There should be a video of it that you can watch. So those were all the different things that we learned about magnetism. Alright, now we're going to go to the next lab, which was on harmonic motion. And for this one, you did need to know how to use a stopwatch. So that was a measuring device that we used in that lab. And then you also used a ruler. So if I gave you an object on the exam and I gave you a ruler, could you measure its length to the nearest millimeter? Okay, that would be something that could be on the exam. Alright, what were some of the topics that we did under harmonic motion? So we measured the frequency of a pendulum. Okay, now how did we measure it? So what we did was we took the pendulum, we pulled it out, and we let it go back and forth, let's say 10 times, and we timed it. So we let it go back and forth and we timed it for 10 complete swings. So this would be one swing. Don't say that that's one swing. So it has to go back and then come back to where it came from. So we did that for, let's say, 10 times. And so the frequency then would be the number of times that it went back and forth divided by the amount of time that it took it to do it in. So if, let's say, it took 10 seconds, so then 10 divided by 10 would be 1, so it would have a frequency of 1 hertz. Okay, then another thing that we did was we measured the frequency of a spring, and we measured the frequency of a pendulum, and then we calculated the frequency of the spring, and we calculated the frequency of the pendulum. So you'll notice that over in the column that says math, I give you all those formulas. So how to calculate the frequency if you know how many oscillations it makes, how to calculate the frequency if you know the period. So 1 divided by the period is equal to the frequency. And then 2 formulas. 1 is used to calculate the frequency of a spring, where C is the spring constant and M is the mass. And then the other one is how to calculate the frequency of a pendulum if you know the length of the pendulum. So make sure that you know how to use those formulas. Alright, then we showed what damped harmonic motion looked like. So could you draw a picture of the amplitude of a pendulum as a function of time? If it's damped, what happens to the amplitude? Or I also talked about forced harmonic motion. So under what circumstance does forced harmonic motion occur? And then how do you know that it's happening. Okay, so I'm going to stop the video here, and when we come back we're going to discuss another lab.